Let's use implicit differentiation to find the derivative of this fabulous looking function. So I'm just going to find the derivative of each term. Now the first term is pretty simple. That's my power rule, 15x squared. The second term, now this is a product. It's a product of two functions, x times y squared. So I need the product rule, right? The derivative of the first guy, the derivative of x is 1 times the second term is y squared plus the first term times the derivative of y squared, which is 2y. But you know, every time you take the derivative of a term with y in it, you have to add the dy dx, which of course just means the derivative of y. I could write y prime, but it starts looking confusing if I do that. All right, I have another product rule here. I have negative 5x cubed times y cubed. Now this negative 5 I'm including as part of this first term. It wouldn't make a difference if I said the negative 5 is part of the y term, but I just usually do it in this order. I think it'll work out best. So the derivative of this first term, again, this is the product rule, negative 5x cubed is negative 15x squared. So derivative of the first guy times the second guy plus the first guy, negative 5x cubed. That's a little bit weird having a plus negative there. Times the derivative of the second guy is 3y squared dy dx equals the derivative of 8, which of course is 0. That's a constant. All right, so this is a rather messy looking thing, but I know that all of my terms that have dy dx need to go to one side of the equal sign, and everybody else goes to the other side of the equal sign. So maybe I'll move these to the other side, and I'll keep these two guys on the left of the equal sign. So I'm going to move this 2 in front, really. This is 2xy dy dx. And this term, I'm going to multiply these constants together. That's really negative 15 x cubed y squared dy dx. And that equals, I'm moving everybody else over. I have a negative 15 x squared. I have a negative y squared. And this is a positive 15x squared y cubed. A lot of terms here. All right, almost done though. I'm just going to factor out my dy dx. So dy dx. And got a little excited there. I'm drawing wild, crazy lines there. So now I have a 2xy minus 15x cubed y squared equals all of this business. And then, you know, there's just one step left. I am almost done. It's very exciting. Just recopying all this stuff from above. X squared y cubed. I'm going to divide both sides by this whole thing. 2xy minus 15x cubed y squared, right? So it cancels on this side. And it's going to end up underneath here. So that's my 2xy minus 15 x cubed y squared. So that is my answer, and I'm just going to rewrite it in just 1 second here. Here again is my answer. I just erased some of the work to make it look a little bit neater. But if I had moved things to the opposite sides of the equal sign, I might have ended up with an answer that looks a little bit different. So I'm just going to write this down because this is going to happen to you sometimes. You're going to end up with an answer and all of the signs are flipped, right? The signs on the top, notice I'm changing every single sign. Positives become negatives, negatives become positives. So let me just recopy this. So that is a negative, and on the bottom as well, right? So I'm flipping all of the signs. So if you end up with an answer, and this is going to happen to you, with every single sign flipped, oops, y squared, that is an equivalent answer. These answers are the same, right? It's just as if I took this first answer and multiplied the top and bottom by a -1. That gives me the bottom answer. So these answers are equivalent. That's going to happen to you sometimes. So don't freak out if you get an answer and all your signs are flipped. That's the equivalent answer. All right, it's your turn to give a few of these things a try. Thanks so much for watching. Bye-bye.